Hi everyone, good afternoon. Myself Bidesh, I am working with InnoMinds as a associate director, data as well as SPD area. So today basically already Ravi given an introduction, so I am not going with this one. So I will go directly to my part, like what exactly I want to explain. So this is basically PostgreSQL full text search. I am going to explain like what exactly my experience with this full text search. Okay, I'll take some time so people let's settle down. Okay. Okay. So I am going to speak about PostgreSQL full text search. So this full text search, like we know everyone, like in other area we can do, but the thing is in that PostgreSQL, like how exactly that full text search we can do. So that's the thing basically I am going to explain. And this full text search is really a powerful search technology that enable user search the specific word or phrases from a document or maybe database, right? So this full text search widely used into that e-commerce platform, like everyone knows, like we are using Amazon or maybe we are using any other delivery application. So in that delivery application we are going to search something. So maybe we are just going to search any product. It may be say take as a cloth like pant or maybe shirt or something like that. And the thing is like what exactly the shirt you want, or maybe pant you need a short pant or maybe full. So the thing is like once you are going to search, you are just putting multiple word over there and then you are getting some result, right? So this kind of thing basically now we are using everywhere. So how exactly we can do this thing in Postgres domain? So that's the thing basically I am just going to explain. So full text search, basically Postgres full text search allow indexing document which help us rapidly search the documents. So the thing is like index is there. So we know previously also I think everyone use different kind of database, relation database, and we know like if we are going to use index, obviously we will get some benefit in terms of the performance, all those things, right? So the thing is like how exactly Postgres text search will work. I'll give you some idea. So like first the thing is like if you are going to search in a big text, say maybe one line of text or two line of text, maybe 20 words are there or maybe hundreds words are there, right? Now the thing is Postgres is not this full text is not going to search all those words. So there are some stop word is there. So stop word, what exactly the stop word? Stop word is basically like once you are writing any sentences, inside the sentences you will get some like conjunction like in, the, and then a. So those kind of word basically it will comes under stop word. Okay. So this stop word basically they will find and they will try to, they will basically remove from the string. Okay. We will come to that point later. I will explain a little bit more once I will come to that particular slide. So now coming to the next point, it implements streaming to find derivatives of a root word. So basically the thing is like suppose you are using rats or maybe cats, multiple cats, or maybe running. So this kind of word basically they will just convert it into running, it will take it as a run, or maybe rats it will take it as a rat, or maybe cats it will take it as a cat. Okay. So this is the way basically it will like split it and it will go to your base word. It will not rely on that like what exactly the changes, say like ed you are adding for a particular word, or maybe you are adding ing. So those kind of thing will remove. Okay. And another thing is there in Postgres like rank. I will describe it later, but the thing is rank what exactly it will do. Say rank basically like you are searching what exactly I told. If you are going to the e-commerce site, you are searching with the 2 words. Okay, so maybe pant and shorts, you put both the thing. So what it will happen, if both the word matches, then those things will come first, and if a single word is matching, then those things will come little later part of that. So that's basically the thing is like rank, and this rank is also available in Postgres full text search. Okay. Okay. So let's move to the next slide. So I just give some idea, like everyone knows like Elasticsearch is there, then like why exactly the Postgres. The thing is like obviously Elasticsearch is more high scale level and all those things, but the thing is like for in a relational database, like how exactly you can do that full text search. So this is basically Postgres is providing a support, and the thing is this Postgres, what exactly it will be benefit like for that small and medium kind of data set. Okay. So obviously if you are working with a large set of data, then you have to move to that Elasticsearch kind of thing. But there are another few things are there, like this is basically Postgres, you will get it inbuilt, but the thing is Elasticsearch you have to install it, and their configuration is there. So little complication over there, but Postgres is little bit simpler than their configuration. And the thing is like real time search is also there, but yeah, it is not that much efficient, but it is there. Okay, so I am not going to waste time here, so I have to move to the next topic. So I know like this is very beginning things, but I just want to recollect the thing, like what exactly it is and how exactly you are going to benefit it with the full text search. So everyone knows like equal to is there in normal SQL. We are writing that equal to match, exact match the thing, and then like, I like, everyone knows like I like, it is going to be like any case sensitive. So those are the thing, and obviously you are just adding some percentage over there, then you can search the text, but then we know like why exactly then full text search is coming to the picture. So that thing we will discuss, but let's go another 3 points are there. So between, in and AND, I know everyone use, but this is not properly that full text in a particular column, that full text are there, and it is not going to work that other 3 things like that. So now if I coming to this Postgres full text search, there are different entities are there. One is like document, another is lexeme. This is a very important thing, lexeme. I will explain to you, as well as dictionaries. So first we will take it as a document. That document, obviously everyone knows already, it is mentioned here, a set of data on which your full text search will keep place is called document, right? So document, you can create a document, like say suppose you have a table and there are multiple columns are there. So you can use a particular single column, you can create a document, you can use a multiple column, or maybe you can use a multiple table as well. So the thing is like you just like if you are going to use that single column, so what happened, like there are some functions are there, like to underscore tsvector, and the thing is like you have to only put that particular single column, and then you can search it over there. And if you want like multiple column, then you have to go to that like suppose you are writing that to then tsvector. This is basically a PostgreSQL function, and inside that you have to put that 2 column, and that column that is a operation is there in middle. So you have to put that operation. I will just explain it later. And the thing is same way, like multiple table also is it possible, like you can put a join over there, or maybe you can put a union all, then also you can get it with the 2ts vector. Now coming to the lexeme, what exactly the lexeme? So the thing is like once we are just taking a text column, that means like there is a big text are there, and the thing is first it will split whatever the like sentences are there, all the word will be split, and the thing is like each and every position will be declared. Say first word is the first, second word is the second, third word is the third, and the thing is there a stop word is also there. Inside the stop word, it will remove the stop word. Okay, so whatever the stop word like the, in, a, so those kind of stop word, it will remove the thing, and then it will just create like only say maybe 10 in a sentences maybe 10 words are there, and after that the conjunction maybe 3-4 conjunctions are there. So those 3-4 conjunction will remove, and rest of the thing will be there, and those things is basically they are telling as a lex me. So that position with that particular word. Now coming to the dictionaries. So dictionaries, what exactly it is, like it is already mentioned here, the conversion of the token into lexeme is done using the dictionary. So the thing is the stop word. So stop word I just talked about. So that stop word is also coming inside a dictionary, and the thing is like synonym dictionary is there, as well as the stream dictionary is there. So synonym is like, say suppose I am taking as an example car and automobile. So this is basically a synonym. So those kind of things like it by default is there, but the thing is we can do the customization for our help based on the requirement of your particular project, where exactly you are doing. So these things are there, and then stream is obviously the stream is there, like I already told, like say running is there. So we are just taking only run. So that is basically the streaming dictionaries. Okay. Okay, so this is basically a full stack search. What exactly I just explained to you guys. So this is basically first word breaking is there. Like first we are getting a big string, and then we are just splitting the string, and we are parsing. I told you like say maybe 10 word sentence. One sentence is 10 words is there. Then we are parsing the thing, and then dictionary. So the dictionary is basically like stop word is there, and then synonym is there, and then streaming is there. So those kind of thing is coming into the dictionary part, and after that we are converting all those things and make it to the lexeme vector. So the thing is like you are going to search in a particular column, there is a text is there, but the thing is we are seeing from outside this is text, but the thing is those are not text, those are separated, all word are separated, and the thing is like the base word we are using, there is no past, nothing. So that's the main thing, and then it will store as like tsvector. This is a data type, and this is the type we are just going to store, and the thing is that index is there. So index I will come to the later, like how exactly that index here we can implement. Okay, so there are different kind of indexes are there, I will cover in the next slide later, and like how exactly that index will work. So that is like tree structure way. So that thing basically just try to show you little bit visualize. Okay, so let's coming to the topic like tsvector. I am talking about the tsvector, but what exactly the tsvector and how it will work. So tsvector, it's specifically mentioned here, like this is a function is used to create a list of tokens of vectors data type. So what exactly I told you guys just before a few minutes ago. So the thing is this will, the big string is there, and then it is splitting out. So that's the thing, and then it is creating a token. So that is basically the function. This is the function we have to use to do the thing. And next point is like to tsquery. So tsquery, like in normal query we are putting one parameter. Suppose you are doing one where condition, and then you are putting a particular column name, and then equal to like something we are doing, and then some parameter we are putting. So this tsquery, this is also like it is taking all the parameters, and then it is converting, and after that it is comparing. So this tsquery, it can take as a word, and it can take as a phrase as well. And the thing is there are different kind of option is there. So like tsvector is there, plain to tsvector, tsquery is there, and then plain text plain to tsquery is there, and another one is there phase. So, there are 3 types are there. I will come in next and discuss, but for the time being let us go like how exactly the vector is creating. So, here you can see like select to underscore ts vector, and we are putting the quick brown fox jumped over the lazy dog. So, this is the string we are passing through this function, and then you will get the return here brown is 3, dog is 9, like that. But what exactly this number? The number is the position. You just check da is 1, quick is second, and then brown is there. So, brown is 3. Same like 9 is dog, that, but you can see like d, here is one d is there, one is another d, but d is not available, as well as over is also not there. So, these 2 are like stop word here, okay. But the thing is your position is same, position is not going to change. So, the quick brown, whatever we are omitting the, but the thing is position is there. This position, why exactly we are keeping it, I will explain in next slide, like what exactly the use of this position, okay. Okay. So, I will move to the next slide. So, this is tsquery, I already mentioned. So, right side I just put a small chart kind of thing. So, right top right you can see like tsvector is there, and then tsvector there is a function to tsvector, it is converting to the data type like tsvector, and left side tsquery is there, and after that you can see in middle at, double at is there. So, that thing I will come, this is basically that comparison, and after that rank is there, rank I already told you, but the thing is this is not the right place, there is another slide is there, that time I will discuss like rank little bit more. So, now for the time being let us go to the to tsquery, plain to tsquery, and phase to tsquery. So, what exactly these 3 things, like to tsquery if you are going to use. So, in that case like basically you can use like any single word, or otherwise you have to put a operation in middle, maybe and or something like that. Say suppose that previous slide the quick brown fox jumped over the lazy dog, this sentences is there, right. But the thing is for that particular case, if you are going to search using that tsquery, then you have to put, if you are putting 2 words, then you have to put one word and then another word, then only it will give you the result. But the thing is like plain to tsquery, if we are going to use, then you need not require to mention any parameter in middle, you just put one word and second word, then also it will work. But the thing is there is another trick is there. Say suppose you just put a lazy dog, it will search in plain to text, and if you are putting dog lazy, then also it will come. So, here is little bit confusion is there, like what is coming left side and right side, it is jumping opposite position, they are changing, but then also it is coming with that same. And for that if you go little bit more, then phrase will come, and using that phrase it will maintain the order, that what exactly the order you want to search. So, you have to put that input like that order, then only it will match that same. In that case like if that right side word if we put it in the left side, then it will not filter out, okay. Okay. So, now here you can see double at. So, double at is the operator, like if we are going to write any query where and then we are putting equal to, less than, greater than, something like that, the same thing like here if you are going to match the thing, then you have to use the double at operator to match the thing. And you can see then the next line, once you are going to select the to tsvector and that particular text is there, and then you have to put it like at double at ts query fox, then it will return the data, okay. And I will give you that other 2 example also in the next slide. And this tsquery a few operators like and or those kind of operator also supporting, and there is another thing is that proximate this operator. So this is basically like a very useful operator, and if you put this thing like the order what exactly I mentioned, that is also possible with that 2 tsquery. Okay, I will explain those things also. There is another slide, I think. Okay, so what exactly I told, like word search and then phrase search. So this is here, like you can search the word in the full text of the document. Search terms can either be individual word or phrase. So maybe a single word you can use, or maybe double word you can use over there. But you can see there is another thing is here. You will face another issue while searching for a word like query, and which may be present in its plural form. So queries. So in that case, like if you are going to use like, and you are going to put queries, but it was inside the text queries was there. But the thing is, if you are going to use that 2 tsvector, then queries will convert to query. But that like case, it will not match, because both are different, right? So the text is fully different, so it will not match. Okay, so coming to the phrase search, the full text search is helpful if you wish to find a word in a document. However, if you want to seek a phrase in the document, you can't rely on that full text search. So that is same thing like what exactly I told. And there is another document, like I have put another line. Now that is same thing like what exactly I explained just. Now coming to the down below, so you can see here I just wrote one statement like select document ID, document text from documents, where document token at tsquery, jump and quick. So this is basically that same reference I am just taking here, and we are just searching these two words, jump and quick. Okay, and here you can see like jump and quick is here, right? And here also you can see jump is here and quick is here. So that's the reason like both the thing is coming up, because here we are using like tsquery. So if you are using tsquery, then obviously it will give. But the thing is, if you are not using tsquery here, say suppose you are using only the jump and quick, in that case it will not filter. Okay. So that proximate operator I told before, that what exactly the proximate operator, but the thing is like I just want to tell one thing here. So this query is here, but no one think about this document token. What exactly the document token? I put it here, but there is no relation between this query, right? What is document token? So document token I will explain later part, but for the time being you can think like document token is like 2 tsvector of this document text. But I will give you the explanation like why exactly I put it document token here. There is a story behind it, I will explain in the next slide. Okay, so here also I just put a document token, and the thing is like you can see here proximate operator we used, jump and quick. Now the thing is jump and quick, so here you can see like continuous order is maintaining, and we are getting only the one record, but in the previous you can see like here we are getting the 2 record, right? And here only the 1 record it is going to filter. Okay. Now the thing is coming to the next point. Initially I told like we can do it in a single column, we can do it in the multi column, or maybe different table may also we can go, right? So now here you just check like we are using multiple column. Say in this particular table like name is there, document description is there, and then document text is here, right? How exactly we are using? At the run time we are just putting where condition and then tsvector name, this TSCP and document. We are just combining and then we are going to search it Avon. So where exactly this Avon is going to search? A1 is going to search in all 3 fields. If any field we are getting the thing, it will give you the data. So, you can think like if your table is there, multiple columns are there, and now you want to search a particular word, it may be present in a first column or maybe second column or maybe third column, then you can use this kind of thing to get the result. Okay. Now, coming to the documents token. So, I told like document token, I will just explain you. So, like how exactly document token you can generate. So, document token basically like we have to add one column document token, alter just table and then just put it, and its data type should be like tsvector. And what exactly the thing is, update and set document token, we are taking like name and document text. So, once you are creating a table, you have data, and the thing is if you are going to search at the run time, it will take time. Okay. But the thing is like in production, how exactly you can improve the performance. So, that is the main reason basically we can add another column, combination of all those things, and then put it into another column name. Okay. So, that is the main reason here, like document token we are using. It may be document whatever you can put your name. So, that is not issue. Okay. So, this is the document token. Here also you can see like that is the reason I just put it in a bold word little bit. Okay. So, next I am coming to that at operator. I already mentioned like why exactly we are using that at operator, and here I just want to show you one thing, like you can see like select tsvector description at jump. So, the thing is from that one table is there. So, jump is going to find it, but the thing is this quickly one it is not going to find, basically as unable to display all the data here. So, this quickly, why exactly it is not able to find, because quick is there, quickly is not there, and the thing is here we are not using any tsquery, and in that last portion you can see this is basically another query, this area. So, I just taking this from select 2s tsvector description, and then you just put this one. In that case like you will get the result, because this is going to match with the quick with tsvector. Okay. I think it is clear. Okay. So, let us go with another topic. This is very sensitive topic, like full text search, what exactly we are doing. The index is there. So, how exactly you can do index? There are several kind of index are available in Postgres full text search. So, like B tree is there, hash is there, and then a PS GIST is there, and then GIST is there, GIN is there. So, when we will use like what kind of index, there is a logic behind it. Like once you are using your like a particular project purpose, you have to understand like what kind of index you are going to use over there based on the functionality. Okay. So, yeah, here it is already mentioned like what exactly I told you, like this for that particular environment. So, once you are going for the production environment, obviously you are going to use index, and then the thing is like document vectors or maybe whatever it is, you just put your name. So, basically you have to create that particular column, say maybe 3 column you are going to search. So, you just create another column and put it as a like TS vector, you just put it like this way, that combination of all those. Okay. So, that it will give you the better performance. You can analyze the thing with the query, and you can identify like what exactly the time it is taking for that first without index, and then maybe run time you just put it this condition, and after that you create this one, and later you just run another query and analyze the thing, you will get the difference, it will huge difference it will be. Okay. So, now coming to the index. So, I told like there are multiple indexes there, but today I am going to cover only these 2 for the time being. So, GIST is there, and GIN is there. So these two basically people use more, and the thing is like GIN we are using more because of reading time. It is give you the better performance than GIST. But the thing is GIST, like suppose you are inserting the thing and updating multiple times, and so like read write operation is more, that time you can go with that GIST, and if you are read will be less. Okay. But the thing is if read is more, then at that time you should go with the GIN indexing thing. Okay. So how exactly we will do? So this is basically that syntax. I just try to put it little bit here, and you can specify that using GIN, and if you want like GIST you just use here, and create the index, this kind of thing. Okay. So we will go next slide. This is basically the ranking. So we covered like search, single search, phrase search, and then now we completed index little bit, and then ranking. So ranking I already told you is like how exactly you are searching the result, what exactly the meaningful, corresponding the meaningful record should come on top, right. So that's the reason basically this ranking is coming into this picture. And the thing is like say suppose you have one column, and in that column maybe 1, 2, 3 columns are there. In that 3 columns run everywhere is there. Next column maybe you have in a row maybe 2 column is there, and 2 column we have run. And then third column, third row, if we are going the third row, maybe only a single column we can see like one run is there. And the thing is if you are going to the query, parameter query using that run, then what happen, that first row will come first, second row will come second, because the number is matching, more matching will come the top level. So that's the reason like ranking is also there. Okay. And next we can talk about that weight. Weight also we can use. Why exactly that weight? Say suppose you have one column, and in that particular you have one table, and the thing is like you have a name column, you have like some description and some another text is there. But the thing is like, so suppose you are going to search anything, you are giving a priority. Okay, I will give you the priority to the first column. You should check that text, if it is in the first column, then it should come first. And then if you are telling like no, I want to give you the second column as first priority. So if the data is matching with the second column, that particular row will come first. So that's the basically weight is there. And weight basically like once you are going to define, so you have to do like this A, B and C like that way, but by default it will take the numeric number. So 0.1 something like that it will usually take, but the thing is you can do it like A, B, C, like this is the way. So you can do the thing. Okay, so this is basically the thing, and obviously I forgot to tell you guys like how exactly this TS rank basically you should use like order we have to use here, and then TS rank you just put it, and whatever that particular column, and then you just put the query, so that you will get the data. So that's the thing. And the thing is like I put some few of the exercise like whatever I explained till now. So there are sample things I just put it there. So those are like same thing, like first it will like just normal tsquery search, and then multiple things are there here, multiple columns are there, and after that you are just changing the you are just adding one column, and then you are putting all the data in that particular new column, and you are finding something. And this is basically like because of we don't have that machine for the time being, like we can see that using this type of query, if you are using explain analyze, and you can analyze the time and performance, like how exactly it is working. So this is overall today's my session. I don't have anything else for now. So That's it. Thank you all of you for listening. Thank you. Good to you. Huh? What? Questions? Hey, we'll take it at the round table, na? We'll take it at the round table. Huh? Yeah.
What's the difference between full text search and fuzzy search? Which you said Elasticsearch has fuzzy search. What exactly is the difference between fuzzy versus full text search?
Fuzzy search, this is basically a little bit advanced. I'll give you the explanation, no issue. I'll give you there, okay. I'll be sitting with you and I'll explain to you. This is little bit advanced, but it is okay. But the thing is, immediately you will not get that thing, but I'll give you some context behind that and then I'll explain.